Okay, hello everybody. I think we will get started. Go ahead. Hello, I'm Jingyu Shao. I came from Microsoft. And today, during this talk, I will introduce a tool called Message Analyzer, which is a quite useful tool developed by Microsoft and used to track the online traffic. And you probably think there are already many of that tools from different companies, but so after today's talk, you will see this tool is actually providing more help, more support on interoperability, especially in terms of our open specification. So you can using this tool to get what is going on online and how the online traffic can be mapped with our open specification and protocol documentations. So the agenda is pretty straightforward, so I will introduce the tool directly and introduce how to use the tool to do the protocol analysis and typical scenarios you can use the tool to gather traffic, gather data, and also this tool can be used to share among the community like different resources. So of course it's a tool you want to know how it works from a demo directly. So now I'm going to show you through a demo. So this is the major user interface. Oh, a little bit not that clear. Okay, so this is the major user interface of the tool. Let me try.
Otherwise, we're going to fix the resolution.
Here.
It's go down. I think it was further down.
This one?
Not that. Maybe. Yeah, I think it was one. I think it was that one.
Okay.
Yesterday we found out, but I never wrote it down. Let's try it. If not,
does it look better? No.
The changes.
It's still the same.
It was like an old-time resolution for this projector.
Okay, this is one, this is two.
You will have to manually resize the window.
Yeah. Awesome.
Okay. Yeah, I can do that. Yes, so if you can see it clearly, so please feel free to sit forward. And so this is a major user interface, and like you can see from other typical tools of like Fiddler, Wireshark, so the message is organized as different frames of each line. And I will go ahead started to do some capture on this is my Android phone. And I will do the email account, do something with my email and trigger some exchange ActiveSync traffic and use this tool to capture the traffic so you can better get a clear understanding what this tool can do. So now I will, so in order that you can all see what I'm doing with my phone, I will project my phone through this IE so that you can know what I'm doing. It's a little advertisement is playing before I actually can start to use the tool. Use this app, yeah. Okay, now you can see, so I'm doing with that and that I'm moving around. So that's a proof I'm using this as a live demo. So I will go to the email account here. So this is the president at outlook.com. Hopefully you can see a little bit Outlook there. And I will start this message analyzer tool, and I will start a new session. So there are typically two ways to input data to this tool. One way is through live capture. That means you do something on the line, and at the same time you start this tool to capture the traffic triggered by the app or software or application. And the other way is from files. That means you can input data previously saved by other tools. So we support different kinds of file capture formats like the network monitor.cap format or wireshark.pcap generation, or even we support log files formats, trace formats. So I'm going to use this lab and start. So here are, so first thing, there's a target computer. That means I'm going to capture the traffic right on this desktop, this laptop. And I will select a typical scenario, and unencrypted HTTPS. That means it can, so the online traffic is HTTPS encrypted, and it can decrypt it into HTTP. And I will leave everything as is for now, so that it started. You can already see a few of the HTTP, and already see the ES exchange, MS, AS, CMD. I hope you can see that. So here, the module name is the different protocol name. So for this mail account on my phone, it's using Exchange ActiveSync for communication with the Exchange server. So it is using this particular protocol, MS, AS, CMD. And there are many different operations or messages defined in this protocol. So it is showing, now it is doing a folder sync under the folder hierarchy namespace, a folder sync message. And you can also see other HTTP traffics in between that's caused by different apps on this phone. So I will, to make it clear, I will filter only the ASCMD stuff now. Okay, so that looks more clear. And I will go ahead to open the project of the phone. Yeah, I will go ahead to start click on, cancel. Go to my inbox, and I will new email, and I want to send to the other account I have here. So it's searching for all the mapping ones, and I will CC, copy this. Copy this address as well. And so now you can see as I'm doing that, there is a search request command. And it is, if we further click the details of this message, it is searching the GAL global address and for what I inputted. And we can get from the response, yeah, how many results at mapping. And also, I put the other address here, and it is searching and the response. And now let's go back to send something. It's a little bit slow for the connection. And I'm going to go ahead and send it. Okay, it's already sent. And now you can see there are compose mail, namespace, the send mail request is sent it, and all the information contained in that mail content, yeah. And also the response command use the send mail, and no fault means that the response is sent out successfully. And also it is keeping ping the server whether something needs to update locally to keep sync with the server, and also syncing for the amount for the mail I just sent out. Okay, and further we can do other stuffs. Oh, sorry, it's a free version, so this pop-ups that kind of advertisement from time to time. And we can do other stuff with the mail account, and typically they are using different kinds of ES operations. So for example, we can show all the folders, and that will trigger the folder related operation defined in the protocol. Let me new. Create a new folder. It's here. You can delete this folder. And as you can see, all the folder create, folder update requests and responses are triggered through here. And another thing, so this is typically you can use a tool when you develop your own implementation. Maybe you develop an Exchange client side or Exchange server side. You can use this tool to do something on the line and see what is actually happening. Or you can just do it with the Microsoft Exchange server and understand how the Exchange server behaves and how the typical Outlook or apps on your phone is behaving to trigger different operations to achieve certain of your purpose. And one more thing I do want to talk about is, so the message here is organized according to their different transportation stack. So everything starts from ETW, that is event tracing for Windows. So this tool is using the event tracing framework, and the event tracing providers will tell the buffer what is happening with your different software. So each software or app contains different event tracing providers. And if something happened, some communication happened, and then that provider will trigger certain events, trigger certain messages to the buffer, and the buffer log all the messages. And the buffer can give in time of the log to the ETW consumer. So in that way, we can log all the messages. And after that is we use a proxy in between to interpret the message. And so from here, you can see the payload is not that straightforward, and some of them are further encoded. But after that is the HTTP layer and the Exchange AS HTTP layer, which are still the transportation layer, and we further decoded that into the MS ASMD layer. And from here, so under this transportation layer, you can still see the body is encrypted. So if you are familiar with the ES protocol, it's WBSML, so which cannot be interpreted easily if you are reading them. But after we have the ASMD parser here, we can just decode everything. So this part, the payload of this part and here are exactly same raw data, only we further decode them into the XML format, which can be human interpreted. Yeah, here is generally how this tool is working. And let's go back here. So now probably you already get a basic idea of what is message analyzer. And so it's developed by Microsoft, and it's a successor of the previous Microsoft Network Monitor tool. But it's not only doing the monitor of the online traffic, but also it analyzes and diagnoses the traffic, and also provides more support in terms of interoperability. So now we are talking about protocol analysis with this tool. And before that, a very important concept of the message analyzer tool is parsers. So parsers are what we are using to really interpret or decode the messages online. So message analyzer works as the foundation, the basic tool which can capture the online traffic. But if you only capture that, it's only raw data, binary data, which can't be interpreted. So on top of that, we build a bunch of Windows layer or common public transportation layer parsers, like the core networking, so the HTTP, TLS, TCP, IPv4, IPv6 are all in this kind of parser group, and they can be, so as far as the traffic is HTTP traffic, it can be analyzed, parsed the binary as a HTTP layer here. And also we have different, so these are the common industry standards, protocols, and also we build on top of that is the Windows specific parsers, like the Microsoft Windows file sharing, so SMB, SMB2, Adobe just demoed is following in this category, and the RDP remote desktop, and also other Microsoft protocols parsers are built on top of that. But we not stop there. Further, after that, we developed different Office parser packages. So for example, we have the Office and SharePoint parsers, which can be used to interpret the SharePoint traffic online. So for example, typically you can use a Word and you save the Word or edit the Word and onto SharePoint site, and that will trigger certain SharePoint traffic like the list WS and like the famous file sharing FSS and the WOP messages online. And also another one is Exchange ActiveSync, I just demoed there. And also we have the Exchange Web Service, MAPI, FSS, and the Skype for Business, different group parser packages. So in this way, the raw data gathered here gets interpreted layer by layer according to the transportation stack. So you can see on the top layer of the display, you can understand the traffic, understand the message online. So I'm going to give you more introduction about the Office parsing results following in different category. So I'm going to open this tool. Oh, sorry. Let me stop this first. And now, so I just demoed how to get live capture file, live tracing, and another way, as I said, we can just input a previously saved capture file. Maybe from your colleague, he saved some capture file and which you want to share to you, or you gather from other tools and you want to analysis with our parser. So we can open different kinds of supported formats. Like I said, we have the Wireshark compatibility as for the PCAP generation. And also we can interpret the log files here and other different typically used for capture file formats. And now let's open a MAPI capture file here. So you can see there are TCP layers, which is already the top layer, nothing on top of that, and also TLS. I will show this later how we can deal with the TLS. So for TLS, you maybe cannot, it's all encrypted, you can't understand pretty well, but we have ways to decrypt that as well. And so let's go to a specific message here, probably Yeah, this one. This is a typical MIP operation, and its transportation stack is RPC over HTTP. So here you see two TCP messages. So we have reassembled those TCP messages together as a HTTP payload, which you still right now can't interpret it well. But further after that, we have the RPCH and the MS RPC there, which is interpreting the data piece by piece. So now you can see the raw data here gets a little bit better as we interpret the different headers and different fields of that. But still, there is a stub data which is not passed yet. So you can kind of thinking that the data online is different boxes, and we unwrap the box once after once, so one after one. So, and after that, we further interpret the step data with this OXC RPC there, and more data gets interpreted into different fields and values here. And there is still a RGB in field has the payload not interpreted yet. And then we use the OSC ROPS protocol to understand the RGB in payload, which is a open, you can see that from here clearly, it's a ROP open folder request. In the request list, yeah, so everything gets pretty clear here. So all the different fields and their values get showed up. And also, so you are seeing me clicking on those and showing the field data. And also we can map with the original binary data here by clicking on this tag. So when I click on different parts, it's locating with the different binary raw data related. Okay, this is for the MAPI. And also we have that for the FSS is open. Another, so by the way, these are the capture files we gathered using other tools like Netmon, like Wireshark, and later we can use this tool to interpret all the different formats. So now it's parsing using all the parsers available to understand the traffic. And then let's go to a particular frame to see, yeah. So here is the FSS request. So it's for file sharing and coarsing. So you can save a Word document or what kind of document on the SharePoint site, and different people can coarsing on the site on the same document together. So this kind of communication triggers the FSS and the WOP messages. So it's requests. So it's still showed up according to the transportation stack of this message, and everything is interpreted clearly here according to our different fields. Okay, and next one is the Skype for business. So it's previously called Link, and we recently renamed as Skype for business product. So we have parsers for them as well. So it is using the term protocol, if you are familiar with that, as an industry standard protocol, and it is based on TCP layer. And again, the TCP layer has its headers and a few bunch of different fields interpreted well, but it still has the payload as a TCP payload. And then we further use the MS term protocol, which is an extension to the standard term protocol. And we interpret the payload. So now you can see the framing headers, the different type, the field length, and TCP framing header, and followed that is message header and the different attributes contained in this particular message. Okay. Okay, so another very important point of the parser and the message analyzer here is it can shows you how to diagnose the traffic. So we provide four kinds of, actually about four kinds of different diagnosis information on the UI so that you can easily understand what's going on not quite correctly on the line. So these are typically errors and for the online traffic, and those are the pinpoints where you see problem with your traffic. You want to troubleshoot them, and so what's the difference between those kinds of diagnosis information? So for validation, that typically means that the online traffic in between captured is not conformed or consistent with our protocol documentation. So either the structure is not correct or the certain data is not correct according to the protocol documentation. So that's a conformance error. And that's a soft stop. So just means that this particular field is not correct. I will stop passing here, but I can continue passing the other fields of this frame or other frames. But compared with that is the passing error. Passing error is a hard stop. So that means if something goes wrong here, I can't further continue to pass this particular frame. So take, for example, for the HTTP traffic, we had the HTTP header as a content type. So content type can be anything. This is string, it's text, it can be anything. But only if you can really understand what is this particular content type, you can further to decode the payload. So if you can't understand the content type, then that is a passing error here, and you can't further continue to decode the payload part. Okay, and another one is application error. That means that the traffic is conforming to the protocol, but there is actually something wrong with the product on the product side. So for example, I send one request and I'm expecting a response or ACK as the TCP example, but without getting the ACK, I resend the TCP request again. So that means that is a protocol conformance consistent behavior, but that means something is lost on the line. So this kind of information is as application error. And the last one is insufficient data. That means that, for example, we saw that TCP is reassembled, several TCP frames reassembled as a meaningful HTTP or higher layer, but if not enough frames, meaningful frames can be reassembled, that means insufficient data. And last one, multiple error is sometimes one frame can contain different types of errors or warnings, and that combines to a multiple error. Okay, I can show you a quick example of how one kind of diagnosis information can be easily seen from the UI. So here is a WOP live capture, and typically the error information is in this column, and you can see they are organized as the different type of diagnostics information. So this is an application error, and also we further, let me filter that to focus on the WOP messages only. So here we see there are some validation error or warnings complaining this particular frame has something wrong with certain field which is not conformed to our protocol documentation. And also this kind of mixed error, different errors means two or more different error types appear for this frame. So in those cases, it's very easily for engineers to, or IT admins to understand among all the traffics there, which particular frame is causing the problem. It's very easy to pinpoint and for troubleshoot. Okay, so to recap, as I have demoed that, we can see the message analyzer can be used on different platforms, can be used on Windows, and also I have tried that on MacBook, and I can capture the Mac Outlook traffic, which is using EWS, and also use on different phones, Windows Phone, Android, or iPhone, to capture the online traffic between your phone to the service provider, and also can be used for different software or apps. Okay, and so here is a little bit of a different comparison of different online traffic capturing tools. So for example, if you have ever worked with network monitor, so everything is listed there online. So every frame, you can see all the TCP frame there, but actually they are the same. Should be resembled the same frame to stand for something meaningful. But in network monitor, you see all of them listed there, and the SMB and the upper layer here is just following on the first TCP frame. But for Wireshark, it do a little bit of a reassemble, and it will put the upper layer on the last fragment of TCP frames. And here is how Message Analyzer is doing that. So we put a virtual reassembled TCP layer on top of the individual TCP fragments. So here on the UI, you will see a reassembled TCP here, and everything up there is based on this reassembled TCP. So it's very clear. You can see the different frames online and how they are grouped together. And if you are interested in only the application layer or upper layer, you can just see the top layer and ignore how the things are organized under there. But if you still want to see the lower layer like TCP or even down there, we have ways to the viewpoint, which can allow you to see everything just under the TCP layer, not the top level. So let me show you quick. So probably for example this one. So now you can see the top layer is different, like HTTP, RPCH, RPCE, and the different ROPs. And you can use we can use the filter that as I'm only want to see everything under TCP. So and apply that. So now it's everything under TCP layer. You won't see what it has passed the further up there, and you can see only the TCP. So another thing I want to mention here, let's remove this. And so you can still see the upper layer is, you can easily group the frames according to what you need. So for example, if I want to group them into according to different top layer here, I can right click the module and group the module here. So now you can see the messages are grouped according to their top layer difference. And you can see that each individual frames inside of different group. And also we can do a second layer group. So for example, for those RPCE messages, I want to see all the destination according to different. So this request and the response, I probably only focus on the responses, so I can further group according to the destination. So now here are two levels of grouping, and you can see under this module, and it's grouped according to the different destination. So there are a lot of rich features in this tool, so you can play with, and it's very helpful. And another thing I can mention here is, so typically for a particular message, we always using in most cases we will use the analysis grid, which is just this grid as other tools. But we also provide many other kinds of different views of the same message. So for example, we can new a viewer of the same message properly. For example, this protocol dashboard. And now you see this is the second view of the same message. So it's located under the same capture file. And if you click this is the analysis grid. And you click this is the protocol dashboard. So that means it shows how many different protocols have been used by this particular capture file, and how many of different protocols are taking the bandwidth. So you can see this is the timeline. So you can see at a particular time spot, so each of the different layers is taking how much of the bandwidth. So that is helpful when you analyze like something like bottleneck on the network, something doesn't happen on the network as you expected the right time. Yep. Okay. Yeah, so this is a recap of what has been shown. So when there are multiple different frames on the wire, so network is organizing them, showing you each individual frames. And the Wireshark do is a little bit different, but message analyzer group the lower layers. And you can see the TCP up TCP, or you just want to see everything under TCP is still there. Okay, so for other typical network tracing scenarios, so for example, problem is you typically may run into the situation that you want to capture certain traffic on your server machine, but the server has a limitation on how many software or what kind of software can be installed. So message analyzer provides a feature of remote capturing. That means the server machine doesn't need to install this tool at all, but this tool can remotely capture what's happening on that machine. And I guess I don't have enough time to show this, but if you're interested, I'm here. And another typical example is you may want to capture the traffic day and night and always monitor the traffic. And if certain things happen, or probably you want to just capture for 5 days or 7 days, and you will stop. So we provide the PowerShell scripts, which you don't need to open the tool and do that manually. The scripts can help you to do the capture automatically. So this is a very easy example. You start a new trace session using one of the providers, and you save the captured file somewhere, and you add a provider with this particular session, and you start a trigger that related list trigger with this session created, and you just start this. This is very simple. You can define more complicated scenarios, like I want to stop when certain error happens during the capture. So it's a very convenient way to do that. And I will, okay. So for the TLS encryption problem, so we can allow you to add the certificate into this tool so that it can help to interpret the encrypted messages as decrypted. So this has a decryption option here, and you can add the certificate you get issued from the server and put it into there, and the certificate helps you to understand all the encrypted information. And also I want to mention there are asset sharings for this tool. So you have seen this tool has, this is the asset manager. So it has different kinds of resources can be shared. So for example, the different parsers that I mentioned, like the Exchange one, Office one, or Windows one, different people can create different parsers and can be shared for the community. So it's very simple that as you just give a feed, or as simple as a shared folder path, as far as the other people have access to that, and people can add that feed into the message analyzer and be able to download what others are sharing. And also like the tracing scenarios, we provide a few of the, many of the default scenarios we'll probably most likely to use, like the Bluetooth, USB, and it can also, other people can also support and provide more different kind of scenarios here. Okay, and here is the resources mentioned where to download. This tool has been released for more than a year, and we are continuing to upgrade the tool and the parsers. And also the operation guide will have blogs to tell you step by step how to use the tool. It's quite helpful for me. I hope that's helpful for you as well. Okay, thank you.
Any questions? I'm going to have to go back and forth because we have only one.
Yeah, one thing I was wondering is that we have found while working on MAPI some parser issues, right? And one of the questions is how can we help? Basically, do you have guys any plan on opening the parsers so that we can just like fix it and provide some you know.
Thank you for that. Thank you. So it's quite easy to access. So for example, this is a MSA CMD. If you right click here and you go to the definition, here is the parser. Yeah, all the source code are here. And it's also in your local app data, all the I know Office has 166 parsers, and Windows has a bunch of them all, and all are there. Yeah.
Is there an online repository where people can submit their updated parsers?
So for now, we are using the Microsoft Azure service, cloud service, to publish and store all those parsers. And people can use their own storage, what kind of they want to, as simple as a file sharing or SQL server or cloud server. So we currently don't provide any kinds of storage yet, but it's free for other people's choice, what kind they want, yeah.
No, what I was wondering is, say, Julian goes and modifies this parser,
Yeah,
and he thinks that it's useful, so he can share with Microsoft.
Yes.
Okay,
Yeah.
okay.
Yeah.
I just wanted to say that the parser itself, it is using OPN language, Open Protocol Notation, which is C#-like, very like pretty much like C#. So, Julian, you'll understand it just by looking on it. Yeah, and it's quite powerful. It was designed to allow to describe protocol in very formal way. And by the design of this language would allow, if you do it right, would allow to generate documentation, prototype, test suite, and parser.
And one more thing, you don't need Visual Studio to do that. You can do that on a notepad. It's quite simple. Yeah, yeah.
We do a lot of decoding of radius packets, and these days they're nearly always SSL encrypted. I know it can decode HTTPS and LDAP-S and maybe RDP, but is it possible if I wanted to extend it to upload like the private key from the server and decode inside radius packets, fragments? There's certain fragments of the packet that are SSL encrypted. Can I pull them out and ask it to decrypt them?
Yeah, you can. So that's one of my demos. Don't have enough time to show. So you can just ask your let the server issue an certificate, and you can just input the certificate into this tool, message analyzer tool, and it will interpret, pass, analyze, decrypt all the encrypted message frames. Yeah. Is that the question?
But it's probably not supported one that you recognize now, the protocol like HTTPS or LDAP-S. I've tried to decode radius packets with it and just says I don't know what that is inside the SSL part. Wireshark's the same. It can do HTTPS and LDAP-S, but not the SSL part of radius packet. If I had to, write a plugin, it's okay. But I need to know, can I say to your decoder, this part is SSL encrypted. Please use this private key I've given you to decode that.
But I think the key is related with your server, but not something we can give directly. It's individual issued by different servers. Yeah, you can import it from into the tool, and it will be. You don't need to write some kind of plugin. Just put the certificates into the tool, and it will automatically do the interpretation of the encrypted message. Yeah, we can talk more. Yeah.
Hi. Do you have perhaps some sort of programming API so I can do sorts of stuff like embedding application, custom application message, for example, if I have custom client server application that has REST API, and I want to provide additional debugging information, those message icons you shown, or maybe I can use the functionality of the messenger embed in certain points of some custom debugging application.
Yeah, for the API part, we do have that for now, and we publish all these together with the tool, and you can use them freely. And we have the like I show on the blog or on the forum how to use those APIs. So you can easily use them to do whatever you want to interpret it and expose those kind of reporting, maybe according to different diagnosis error information types. Yeah, we do support that. Yep. Okay, next question.
Hello, only one question. Is it possible to make this application to run as a service, or to program it for doing some scanning in between some hours or some timetable? A custom one. For example, for 2 p.m. to 3 p.m. I want to analyze the network, but only in this time, or even at night or something like that. Is it possible to do that?
Online?
To program it, to do it offline, not using. This is a desktop application. If I want to do the same, but not with no user or not using it directly, to use it as a daemon. Is it possible to do with it?
Okay.
So the question is, can you do it without human intervention, right? The answer is that if you can, as I showed you in my presentation, that you can capture traffic, you're talking about capturing, right? You can capture the traffic using command line, which is available on all windows. So basically it will boils down to creating a task in the task scheduler, and you can I mean, it just, I haven't done it, but that looks like a reasonable way of doing it.
Thanks.